I want to welcome you here today to the Minnesota Biochar Initiative. And what we have going on here today is our monthly char chats. My name is Jim Doughton. I'm one of the founders of MNBI and also the Carbon Sequestration Program Manager with the City of Minneapolis. So want to welcome you all here. We have a really good program on here today. We got two folks, a lot of interest, and I'll continue in the background trying to get folks on board here. But know a lot of you that are here. Very excited about today's talk. But we have a pretty exciting program here today. I want to introduce here our speakers. And Todd Rexine. Todd oversees and coordinates Great River Greening's conservation staff, ensuring that conservation program meets the organization's mission of nature-based climate solutions. He also specializes in project management on natural system management in the urban interface. Todd also directly oversees Great River Greening's climate-related projects around biochar and urban tree canopy. Before coming to Great River Greening, he was in the landscape installation and sales field and brings significant logistics planning and installation experience. And he is joined today by Christopher Klatt. Chris, a Ph.D. graduate in ecology and environmental science, manages ecological restoration projects in wetland forests, or floodplain forests, I should say, wetlands, shorelines, and upland habitats. Join here, or you, oh, never mind, that's another part. Along the Mississippi, Minnesota, Vermilion, and Cannon Rivers in Dakota County. His work aims to preserve wildlife habitats in the highly developed southern Twin Cities metro area. Before Dakota County, Chris conducted research at Oregon State University, Swedish University of Agricultural Sciences, and the USDA Agricultural Research Service. We will be taking questions along the way, but please hold your questions until the end. If you got something you'd like to put into the chat, put your questions into the chat, and we'll also be doing calling folks out after this as part of the questions and answers. But feel free to add it into the chat during the meeting. With that, I will pass off to Todd and Chris.
All right. Thank you for everybody for coming in today. I'm just going to share my screen with our slideshow here. Okay. So yeah, like Jim introduced, I'm Todd Rexine. I'm the Conservation Director at Great River Greening, and we'll just do a quick introduction of who Great River Greening is, and as well as Chris will introduce Dakota County as well. So Great River Greening, we're a nonprofit organization located in Minnesota. We started back in 1995 as a tree planting effort in St. Paul along the Mississippi River, and since then, we've grown across the state and we've started expanding into different regions of the state. And primarily we've been doing natural resource management, but within the last couple of years, we relooked at our mission and we've turned our attention towards being more climate focused on our restoration efforts within the natural resources realm, which has led us into looking into biochar as an option as we do natural resource restoration.
Hello, everyone. My name is Chris Klatt, and I'm natural resource specialist with Dakota County. And just backing up a slide real quick, it just gives you a context of where Dakota County is in the state here in the southern metro, south of Minneapolis and St. Paul. And our park system, and next slide, is about 6,000 acres in size. So we're not the biggest park organization in the Twin Cities, but we have the opportunity to do some long-term ecological restoration and management in these park areas over time. And a lot of that has been in collaboration with Great River Greening. In addition to the parks and conservation areas, where we have an initiative currently where we plan to develop pedestrian trails that crisscross the county with a total of 200 miles planned. In addition to those being alternative transportation corridors, we have a goal of maintaining those as native plant buffers and transportation corridors for wildlife. to connect these core habitat areas. So that's another initiative that Natural Resources is closely working with in our park system. Next.
Yeah, so, you know, why is what's needed in the natural resources realm, and why is biochar one of the reasons we're looking at a solution for natural resource management? And this is a project that we worked on, have been working on for numerous years with Dakota County, and it's a restoration project at their Lebanon Hills Regional Park. And this is an oak savanna, oak woodland complex, but in the picture on the left it's been infested with buckthorn, which in Minnesota is a common invasive understory tree, and a problem with both in our woodlands and savannas, but also in our prairie systems as fire has not been part of the landscape over the last century with suppression. So this is a project that we worked on, and this is a before and after of what an oak woodland will look like once we are able to manage buckthorn. And so that's where we're looking at biochar as a possible solution to dealing with all this woody material that we need to remove from projects as we start to do restoration of our natural systems.
And I just wanted to add some historic context to the reasons why we conduct ecological restoration as we do. A lot of times we're looking back in the past history of vegetation cover and the legacy that's carried through soils as a consequence of that vegetation interacting with the geologic landscape. And after the last glacial period, about 11 to 12,000 years ago here in Minnesota, this region along the Mississippi River was largely predominated by prairie, oak savanna, and oak woodlands, as Todd mentioned earlier. And so that often becomes a target vegetation cover that we aim to bring back into a lot of our ecological restoration projects. There's a lot of evidence that, and I'm in danger of being repetitive of our previous guest to this lecture series, Steve Tomford, who I think I saw in the audience. There's, not only are these ecological restoration efforts bringing back fire to the landscape, which was some of that pyrolyzed carbon input from prescribed burns by indigenous land management was incorporated into the soil to create these mollisols, these large organic horizons in these prairie soils that were largely harvested or largely mined by agriculture by plowing, and so a lot of that carbon is now being oxidized and released back into the atmosphere. Next slide, please. And so a lot of times when we're returning these ecological systems to a similar context to what we saw previously, we're mindful that the climate we're moving into is not resembling what was there pre-settlement. However, these vegetation communities that survived as long as they did under situations where there was increased fire frequency are a very resilient vegetation landscape going into a climate scenario in which we'll have warmer and drier summers, especially with regard to the amount of tree mortality that we're seeing due to droughts and insect attack like emerald ash borer. And so by reversing afforestation, we're returning fire to the landscapes and creating a more resilient structure of vegetation that has habitat to a large number of wildlife that are decreasing because this habitat is becoming more and more rare due to afforestation. Now, that goal, that ecological land cover goal, is often at odds with carbon sequestration goals. As you know, as you can see here, that removal of woody vegetation is often burned in and released back into the atmosphere. And so what we're hoping to do with a more thoughtful, careful approach with biochar is to intercept that process and incorporate that carbon back into the soil where we once had it, as opposed to just releasing it in the short term. Next slide. Another goal that we have with ecological restoration efforts that biochar could potentially help with is due to some of the legacy of agriculture in our prairie systems. Oftentimes, in this example here, this was a ecological restoration site that we partnered with in Great River Greening, and in some of the slides that you'll see later in this presentation, where we were utilizing biochar kilns as a way to incorporate that carbon into the soil. And historically, this land use was had animal agriculture in the 1970s. And you can see the legacy of that in the lower figure in 2023, where we have those green patches of largely dominated by Canada goldenrod, Canada thistle, smooth brome, and other vegetation that is largely weedy and kind of a monoculture with very low diversity and opportunity for some of the plants that pollinators love best. And so by utilizing those, by applying biochar to the landscape, our hope is that uncharged biochar has with its high sorptive capacity, has the potential to bind some of those soluble mobile nutrients in the soil column and slow down the process of nutrient cycling in the soil. So if it can hold on to that nitrogen and phosphorus in a longer period and cycle, we have an opportunity to then try to manage the vegetation in a better way to increase the diversity. And of course, this has water quality benefits, as you know, with less nitrate leaching through the soil column into our groundwater systems, causing some of the problems that we're seeing with nitrate levels in our groundwater systems. Next. Finally, one thing I wanted to touch on before we get into some of the results is that we have enormous air quality benefits when we utilize biochar kilns in comparison to our typical plan of open pile burning. And a lot of our restoration work happens in highly developed areas in an urban, suburban landscape. And we often get complaints from neighbors about air quality concerns, especially during COVID. We were very cognizant that we were causing problems with air quality with our burn piles in the winter. This has become more in the public mindset as we experienced a lot of wildfire smoke from Canadian wildfires this past summer. And so we're increasing, and this allows us to do burns in areas that we normally would be more restricted. So this particular biochar kiln, which was set up in Fort Snelling State Park near Minnesota State Highway 13, just about 50 yards away. So if we open this link, you can kind of observe some of the benefits that this has over a typical open pile burn. And that link will open up soon. But as we're waiting for that link to open up, it's typically fire departments that are making that determination as to whether the open pile burning that we've done in the past is going to be a concern to air quality, such that they're kind of the gatekeepers at this point. And so it's really incumbent on us to educate fire departments and invite them out to show them how the use of these kilns can really benefit in that respect. And so in this particular video, I wanted to call attention to how the smoke kind of recycles back into the kiln and reburns it, such that we're getting very little particulate matter as a result of this burn. And this is, pretty representative of a large portion of the 4-hour burn cycle that we see with these kilns, that a significant reduction in particulate air pollution is observed in utilizing these kilns. Currently, the MPCA, the Minnesota Pollution Control Agency, has determined that these biochar kilns are considered to be no different than open pile burns, such that at this time, we haven't been told that we've been required to obtain additional air permits. However, the see Nick Vetch's comment, which is great. However, there is some indication that other types of biochar kilns, like air curtain burners, might be considered incinerators as opposed to open pile burning. So that's an air quality permit discussion that we need to continue to have with the Pollution Control Agency. So yeah, moving back to our presentation.
So yeah, and then so building off what Chris just said is, the question is, so why are we all of a sudden seeing this as a problem? There within the state of Minnesota, for numerous years, there was actually a biofuels program that municipalities or entities would actually work together to harvest the woody biomass from natural resources, and it would all be trucked to a facility that would then process the material for energy production, which worked out great. In those, both the pictures on the side, those are just large buckthorn piles from the sites. Those aren't, we've done it with other materials such as cedars and other larger material that's encroached, but these are strictly buckthorn piles from sites. The bottom picture is actually, we staged at a county park, and other entities brought their material there so we could get mass. But then this material is essentially chipped off, hauled off to 2 different biofuels facilities within the state of Minnesota, and then processed and burned for energy. Smaller operations, if you didn't have that quantity, you were still probably burning the piles. But then there started to be a transition in the energy sector, and starting in around 2017, there was a move, there's more subsidies for solar and wind were actually gaining popularity, and they actually were outcompeting biofuels as far as a cheaper source of renewable energy on the landscape. And so we've seen reductions in, well, actually the plants are now closed, or the one plant that's left it will be closing, and it's now the material is just sitting there rotting. So what's been the answer from contractors and service providers? There's been multiple different ways they've looked at it. One alternative is, we're just going to go in with large mowers and mow all the woody material down. Looks great when it's done, but the problem is now we have all this woody biomass sitting on the landscape that is still contributing to the carbon footprint of the site through decomposition and methane release from the site over time. And we're really not managing the nutrient load on that site either. As Chris was talking about earlier, the nitrogen and all that's just cycling back into the system. We're not finding ways to capture that. The other option, again, just straight up just burning piles on the site. And I, kind of gave reference, the piles in the upper left, those are 20-foot by 20-foot piles of just straight buckthorn from a site. And while it's great to be able out there in the middle of winter burning piles, we also realize that this is releasing all that carbon up into the atmosphere. It's releasing all the VOCs, and we're basically putting these piles down to ash. And in the process, with releasing all that material up, we're also damaging the site itself. We end up with these large burn scars, as in the middle picture there. And that burn scar is 2 years later. The soil itself has microbes and everything have been completely killed off because of the intensity of that fire on that small footprint. And typically all we get are weedy species, if anything wants to grow in there. And it takes a very, very long time to go back and mitigate that problem, because the microbes have all been killed off and everything else is stripped out of the soil. And there's sites where you go back even 10 years later and you can still find the evidence of those scars on site because they just can't heal over time. So this is where, Chris, I'll let you talk about this one.
Sure. Well, and just to contrast with those burn scars, when we utilize biochar kilns, as we'll be talking about more in just a moment, we can use them in much more sensitive vegetation areas. This is an example of an area where, there was a kiln directly on this particular site. And after combustion the following spring, I came back to the site to find spring ephemerals coming up out of the ground. This is a trillium in the center of the photograph here. And as Todd had mentioned, if that soil transformation had taken place with a burn scar, we would probably not see a trillium ever be able to grow in that soil again for decades. Just its dependency on mycorrhizae in the soil, and just the soil chemistry as it was input or as prior to the burn would just devastate plants of this sensitive of nature. And we're setting up vegetation transects to monitor the vegetation with the application of biochar, because there is some potential for nutrient levels to be reduced in the short term with this land application process. But we're hoping that we'll be able to see a lot better results than if we were to try to to seed and maintain a burn scar after a burn.
So what started as a conversation with Dakota County and Great River Green, I think it's almost 3 years ago, maybe 4. We had this idea of relooking at what we're doing with our resource practices, and came up with this idea, and we talked with Chris as part of the conversation as well. And what if we found a way to purchase some Oregon kilns or construct some Oregon kilns, or purchase some ring of fire kilns, get these smaller kiln systems on the landscape, and actually as 2 entities working in natural resource systems, is what if we start looking at how to implement this on a restoration site? So we partnered together, and both Dakota County and now Greening we've started looking at getting our own kilns. But we worked, Great River Greening worked specifically with Dakota County on three sites, as Chris alluded to earlier, with Fort Snelling State Park, Billsby Regional Park. Correct me if I'm wrong on that one, Chris.
Yep, you got it.
Yep. And then there was another one over at Garlow Regional Park over in West St. Paul. And what it was is some of the sites were in the brush was stacked in different ways. So it gave our field staff different ways to look at and also report back to both entities on what the findings were on how these sites need to be prepped, how we need to look at them differently. So, the pictures show it's standard contractors, came in, they cut the material, stacked it. Some sites we had some specifications, but we weren't really sure what our specifications should be on how they should stack it. And we also want to understand how much added expense is that going to be to pre-stack a site so that it's ready for a biochar kiln to come in. Because the Oregon kilns, they're only roughly 5 foot by 5 foot on top. You want to keep your brush within that column of air, so you don't have a lot of brush hanging over. Ring of fires allow you a little bit more flexibility. They're about 98 inches across, just one kiln, and you can also intertwine multiple kilns together. But we had our crews out last winter, and they were working to answer some of those questions for us, for both entities, on how we can apply that to the site. I'm not getting to the side. Oops, too far.
I just might add too that one thing we discovered is that for these particular kinds of kilns, we're limited to processing material that's about 4 inches in diameter or less. And so we're still kind of exploring ways in which we could process larger material. But for hand crews and crews that are, working with smaller material like this, these are pretty well suited for the job.
Yeah. And so I think, some of the lessons learned are, like I kind of alluded to, it's a new process, quote unquote new, because others have been doing it for some indigenous populations have been doing some form of biochar on different parts of the world for, for centuries. But for those of us in the US, in Minnesota, it's a new process for natural resource systems management. And really what it is how do we start talking about that with service providers, other entities, other landowning agencies, and get the word out about this different way of processing that biofuels. Chris also alluded to the permitting. No one really understands how to what the permitting process is. Depending on where your permitting agency is, they look at them differently. And that can be the local fire marshal. How do they view it? Do they view it as a fire pit? Do they view it as an open burn, or do they view it as just doing brush piles? And is all the way up to the state agency. The Department of Natural Resources also has some say in how things are burned, as well as the Pollution Control Agency within the more metro and urban areas. And so there's still conversations about what does the permitting process look like on these, and it changes depending where you're at. And then also you can see within our pictures, we still haven't done it yet. We've done it on one site, but all of the pictures that we worked with Dakota County and Great River Greening worked on last year were during the winter months. And that afforded us a little bit of flexibility with the permitting, because within the state of Minnesota, if we have 4 inches of continuous snow cover, we don't need the state permit, we just need the local permit. So that kind of freed up some of the permitting process. It also helped with our managing the fire itself. Usually we have to have some form of water on site. When we have plenty of snow, we were able to use the snow. As you can see, they're actually scooping the snow right off the site to quench the fire, and it worked just fine. This winter, with the drought conditions that we have in Minnesota, we're already starting to experience some issues about when can we do some biochar projects that we have set up, because we need water on site. With it being 20 degrees or colder Fahrenheit, if it gets below zero like it has been the last week, we have problems with the water freezing on site. So there's some more things that we're working out on how to do biochar in the winter. And then, the final one is just educating and training. We just need to get people out, train them on what it is. The Oregon kilns and the Ring of Fire kilns are very approachable. People can see what's going on. They're not the big giant kilns where you can't really see what's going on, or it's too hot of an area to work in. So there's a lot more to come, but that's where we're looking at, is how do we get everybody educated on this. But there is a lot of interest from landowning entities that we've talked to across the state on how to implement this on their lands as well. And I always refer to Dakota County as they already have, they have some kilns up and going already. So that's always great to have that resource. So last year, what do we do with these sites? It was approximately 20 cubic yards of biochar that was produced from the notes we took, so that's equates to about 100 cubic yards of brush from the sites, and it was primarily buckthorn that was processed on the sites. We have samples. I know people are probably interested. What's the ash content? What's the carbon content? We still have several bags of samples that we need to send off to get tested. But from what we saw with the kilns, they were operating very productively on site. Chris, I don't know if you have anything else to add to the process.
Sure. I was just going to answer Dwayne's question in the chat. He asked, once the biomass has been quenched, how soon is the material applied, and how is the material applied? In the case with I think these photos were taken in February last year, where we had quite a bit of snow cover at that time. So we were able to, without concern of fire danger, we were able to first apply snow into the kilns to do the initial quench, and then immediately, once the kilns were cool enough, tip them over and spread them out on the landscape. So the lower picture was essentially 15 minutes after the picture above. The goal was to spread the material out so it didn't exceed about an inch in thickness. But after freeze-thaw cycles occurred, when I returned back to this site in the summer, I scarcely saw much char on the surface of the soil at all. So it had incorporated itself into the first few inches, or at least the surface of the soil, and spread itself out quite well just through natural freeze-thaw cycles. The I think when we're in a situation where there's less snow available and we're doing this by with water, we have to take a little bit more care. But typically, you know, I from my experience, it's been about, you know, anywhere from 20 to 60 gallons of water that could thoroughly quench an Oregon kiln or a ring of fire kiln a little bit more. To safely apply on the landscape and ensure that everything's cool and to the touch before leaving the site.
Yeah, and I can add to that too. We did one in November where we did an Oregon kiln with a bunch of volunteers. And it was really about teaching volunteers about what biochar is. But we processed a bunch of wood material. And once we put it out, within 15 minutes, we were scooping it into 5-gallon pails to take it back to our shop to use in the spring of this year to use it in shrub plantings at a site just down the road. So if you get it quenched, it cools off very quickly.
And we'll get to some of the other questions about the biochar, and just wanted to kind of give some indication as to where Dakota County would like to go with this. So because we have a long-term association with a particular land footprint, what we'd like to do is try to keep our cycle of biochar production and use relatively small so that we can, you know, kind of from cradle to grave, utilize the char that we're producing. Although we're very open to the idea of becoming a source of material for other uses if it's something that would be amenable to other, because I know there's a lot of interest in utilizing biochar as part of stormwater BMP construction. So if we meet the standards, and one of the questions that Rob Hittala had was whether any testing had been done on these biochars, and unfortunately very little at this point. We had Ian from Clearwater Nitrate Reduction do some initial testing on some of the biochar at Lake Billsby to get carbon and hydrogen ratios, but I think we need to do a lot more testing on these. But one application that the county is interested in is immediately turning around and utilizing some of this biochar into horticultural production for some of our native plant nursery. So we're going to be doing some testing in our growing season this coming year to replace peat moss that we've been utilizing. So as a direct contributor to a carbon sink to instead of a carbon source. Also, we have conservation easements in the county that I had shown a map of earlier. And one particular easement we have with Sharing Our Roots Farm near Northfield, Minnesota, and they're going to be utilizing the kilns to process biochar on their site. And we'd love to hear how it works with their system to incorporate it into compost systems, which can then be directly applied back into their adjacent soils for vegetable production. So that's hopefully, you know, keeping it as local as possible. We're certainly interested in compost amendment applications as well. We lease land to Waste Management at Empire Township. For what is the mulch store, essentially. So we're hoping that we could potentially, if we aggregate our biochar production, we could work with them to create value-added products that they could sell back to consumers. And we're interested in utilizing some of these biochars that are produced locally for some stormwater applications, whether they're just for local store or pretreatment filtration devices in some of our best management practice basins. And we are interested in scaling up. So I know Christy Cowden mentioned that we're using smaller kilns. We are interested in looking at larger facilities similar to Jim's City Minneapolis project that could utilize larger material, because we're constrained at that 4-inch diameter feedstock. We would certainly love to figure out a way to incorporate chipped feedstocks that would be utilized in a regional facility for a larger aggregate production. And I'll hand it back to Todd.
Yeah, so with that, so Great River Green itself, we have a biochar initiative that we it was started in June of this year. We lagged a little bit behind Dakota County, so that's why we were working with Dakota County on it. But we got some funding from the Environment and Natural Resources Trust Fund, which is a funding source within the state of Minnesota that goes to natural resources. And the particular grant we asked for was under climate change, and really was, how do we get biochar out on the landscape? We were looking at not only getting our staff and get others up, but how do we start to train people, collect data, and help get it out there so that if we want to have service providers actually do this on the landscape, how do we supply them with enough information and training so they feel comfortable doing it? So internally, we're purchasing flame cap kilns. We have 4, we have 6 more on order. And those are going to be we're going to start rolling those out here within the next month to get our staff out on sites to actually start finding sites with buckthorn or woody invasives. And then we're going to start collecting data. Essentially, that's what we're going to be doing, is we want to know what's the stem density on a site, how much material, if you have X amount of stem density, what does it take to process that wood and get it into piles, so that we can share that with service providers down the road, so they can understand what that equates to in man hours. Because this is a little bit more labor intensive than just cutting a bunch of trees down and piling it up. You need to process, as Chris alluded to, when you have an Oregon kiln or a ring of fire, you're stuck to that 4-inch feedstock. So what do you do with that other material that's over 4 inches? Buckthorn doesn't always hold itself to that cap at 4-inch diameter. It does get bigger. And we also have other material out there too that is larger than that. So really what we're going to be doing is we're putting together a data collection set within the this month and next month, as we're collecting the data so that we can release that out and actually use that as a way to start engaging external audiences. So talking to service providers, start talking to landowners, fire agencies, and the general public about what the benefits of biochar are, how it functions differently than just an open pile burn. We have a couple actual biochar fires or sites set up for this year already with some other agent entities that's what they're looking at. They have some work crews that cut a bunch of material down. We're going to take a couple of ring of fires, train them in on how to use them. And then we also have fire agencies that we've invited in to see the process so they understand how that fits differently within the permitting process and start to have that conversation. We're also looking at other programs. We have a program related to silvopasture. For those of you that don't know what silvopasture is, it's essentially that back 40 part of land on a farm, on an agricultural property that has been let go. It's kind of overgrown, but now how do you reintroduce cattle or other grazing animals into that system? So it's grazing woodlands is what it is. But those woodlands are overgrown with buckthorn or other exotics. So how do you restore it to a point that then you can open it back up for grazing in the woodland environment? And then also talking to the farmers about what the benefits of biochar are for their agricultural practices. We've had numerous farmers that are already talking to us about what the process is, and they're excited about how they could possibly take that wood waste and not just burn it off, but actually use it as a product back into their fields and into their farm systems. And then finally, it's just disseminating the information out and disseminating the kilns. And what I mean by disseminating kilns is we're going to have 9 to 10 kilns here within another 6 weeks. Let's get them out there. Let's get people to use them. Let's train people to use them. Let's let them have access to them over the next 2-3 years. So when we start talking about that, this is going to be a way to process material going forward, they're comfortable with doing it and their staffs are comfortable with doing it. And then also just doing presentations like this, we are at the beginning of it, but, continue to do the presentations, continue talking to people, educating them on what the benefits of biochar are, share our findings. Once we start being able to have more samples that we can send off to collect data on what the ash content is versus carbon content of the biochar itself. And we've already started some dissemination on volunteer events. We have a kiln that is up in the Camp Ripley Sentinel landscape region, which for those of you that aren't familiar with that is, it's up around Little Falls, Brainerd area of the state of Minnesota. And we're working with the camp as well as land entities up there to get that kiln out and talk to volunteers about it, have volunteer brush hauling events where volunteers are helping us process the material down to different sizes. And then we have staff on hand to burn it. We still haven't figured out how comfortable we are with volunteers feeding the fires, just because of the fact of how hot the fires can get when they flare up, and whether or not we have enough safety clothing for all those volunteers. But we're working through that internally. Is there a way we can train general volunteers to be able to manage biochar kilns as we're doing these on sites? This year alone, we've already produced 23 cubic yards just through demonstrations. And we've engaged 500 community members across the state in this process. And as I alluded to, we've collected a lot of that some of the biochar has gone back in the landscape, but some of it we put in 5-gallon pails, took it to other sites, and then right now it got mixed with compost back in November, with the hope that we get charged biochar ready to do plantings in 2024. What's the future hold? Chris kind of alluded to it. Dakota County is looking at more of a stationary large facility that's a regional hub for processing biochar. Gray River Greening as a natural resource systems manager, we're looking at what's the possibility. The Oregon kilns are great, the ring of fires are great, but in some instances we're burning stuff that's bigger than 4 inches and it's on site. How do we look at processing those materials on site? It's not about taking the material off. It's, if we process it on site, we want to really leave it on site too, so the site can benefit from the addition of the biochar to the soil. So we started looking at what these larger systems, and everything's got pluses and minuses, and we're trying to look through that process right now. But we are considering, whether is it an air curtain burner or do we look at a big box kiln? And for those of you not familiar with the big box kiln, it's about a 7-foot wide by 4-foot high by 12-foot steel box. It's essentially a very large flame cap kiln, but it can be moved around with a piece of equipment. You got a trailer them to the site, but they can also process larger material. You dump them, and if the material isn't processed, you can throw it back in and get it to process. And I guess we'll open it up for questions.
I've been answering some of the questions that I've been seeing in the chat. Rob had a few questions regarding both whether we had used green or dry material. And that was one thing that we were able to kind of experiment with. We had material at Lake Billsby that had only cured for about 4 months, and then some that had been there for over a year. And certainly the dry material burned more quickly, and I think the yields of char for the green material was lower due to the slower burn process, and it probably didn't get up to the same temperature as the dry kilns. So there's certainly differences there, and we would prefer to utilize dry material as much as possible. We don't have particulate matter measurements at this point, but it's something that I've had a preliminary conversation with the NPC about as to whether we could develop an experimental design that would evaluate PM 2.5 in kind of in a grid area around the kilns. And I'd love to compare that to open pile burning, of course, because we really want to demonstrate that this is a benefit compared to the status quo.
If there's any that we didn't.
And Emily Snell-Rood mentioned, where were they fabricated out of curiosity. I found a design plan that said, find a metal shop. I was not sure what it means.
Yes, so the one kiln we had operating, we had it, the one Oregon kiln we up in our Camp Ripley Center Landscapes, we found a local metal fabricator, and that's really what it is. We just found a local metal fabricator up in Brainerd. And we used the design plans and gave the plans that you can find online for the biochar kiln, for the Oregon kilns, and took them over there. The other kilns that we are in the process of getting fabricated right now, we just found a local shop within the Twin City metropolitan area, and it's a matter of just sending out the plans and seeing who had the time and resources to fabricate the kilns that we were looking for.
And Emily, I will add, I'll look that up and tell you the fabricator that we use, but it was a shop in Minneapolis that we were able to work with. Prescott also asks, have you looked at the ROCC kilns by Dr. Paul Anderson out of Illinois? They look like they could have greater capacity and could be trailer mounted. I do recall, I have not looked at that particular design, but I recall a similar question higher up in the chat regarding the capacity of these. And so, correct me, Todd, but I believe the Oregon kilns can have if they're completely filled, have a capacity of about 1.6 cubic yards of char material when it's full. And the Wilson Ring of Fire kiln, when you're just using the 3-panel, I think it's just above 3 cubic yards, but you can piece together multiple panels to make that larger. And I think when we have it at the 5-panel kiln, I think it was just over 6 cubic yards from my calculations.
Yeah, and I think the kilns we ordered are kind of a redesign of what Chris had. So, and they're a 6-panel kiln now, and I think that's what it's almost 6 cubic yards that if they're full, they can process. And I know the big box kiln for sure, it can process 10 cubic yards in half a day. We're still figuring out what the air curtain burners can process.
I saw a question by Ali further up in the chat about CO2 emissions. And I guess just doing a mass balance, what we typically find, from our kind of overall yield of about 20 cubic yards of char as after processing about 100 cubic yards of woody biomass material. I think we're typically seeing about a 15 to 20% carbon yield of char. And so the remainder of that is what's liberated as CO2 back into the atmosphere. So that's a lot better than an open pile burn that would be probably about, less than 2 or 3% of that original carbon feedstock would remain as charcoal. So from that perspective, we're doing a lot better, but of course there's potential, much more controlled situations that aren't in a field setting like this that could probably achieve higher yields.
Well, these have been some really good questions. Appreciate what you guys have been doing here on this issue. One of the things I know the Forest Service is taking is very active interest in scaling up what you're doing here as well with the char bosses and similar materials that can handle the larger materials, those larger things. But that's more of a mass reduction, and the yield goes down with those temperatures. But finding a way, as you mentioned, to take care of these problems in keeping and returning some of this carbon in a stable form back to the soil is something we really need to keep working on. So I really appreciate what y'all have been doing here today in your presentation. We had 75 people show up, which is fantastic. I thought Stephen Tomford might jump in more with a question on nitrogen, but I haven't seen that yet. I apologize for the confusion on getting in here. The original flyer we had was incomplete, needed the password. So we will certainly take that feedback to do better in the future in reaching out to our members. and to those participating in these CharTalks. Just want to remind folks that next month is USBI's conference in Sacramento. If you haven't had a chance to go to one of those, it's very valuable and a great opportunity to link in. I really appreciate the folks that came to this presentation today from overseas, and welcome. So I want to thank everybody for coming on in here. Are there any other questions that people would have? Want to talk about in public?
I was looking for their contact info for both of them if possible.
Guys, you had it up there. You want to get it into the chat?
Sure, I'll post it in the chat.
Awesome.
Anyone else? Stephen, how does it, Tomford, how does this relate to the work that you've been looking at with ecosystem restorations or natural system restorations?
No, thanks, Jim. No, they're right on. They really did a really good job. It was really interesting to hear and people confirming this. Todd and Chris, right now I'm working up in British Columbia, and we are establishing the first of Canada's nitrogen monitoring protocols. And I see this spreading across Canada and then coming down into the United States, finding indicator species, both native and non-native. And the mitigations for these biochar will become a huge part of that. So I think you guys are on the front of a revolution, and I really appreciate your work so much. So keep up the good job, gentlemen. I appreciate it. Have a good day.
Thanks,
And
Steve. That's exciting.
Oh, pardon me. Yeah, no, thank you very much for coming out. Ed, Mathieson, are you listening?
Yes, I am.
Do you have any updates on next month's CharTalk?
Still getting it finalized with Sanjay, but I will report to you, Jim, and we can get that posted.
All right, next month, and this is from the University of California, San Diego, I believe.
UCLA, Los Angeles.
UCLA. And looking at stormwater talk with professor at UCLA. So we're really looking forward to it. We get get that out to you. First time organizing an event on LinkedIn. So we're working on getting that full app out there, and also looking at a better way to list registration to get confirmation and hopefully get it on people's calendars as we move forward. But I want to thank everybody for your time and attention here today for such a valuable thing. Really appreciate the efforts from Chris and Todd on putting this forward, and we're looking at all the scales of biochar and applications. So if there's nothing else, this is what all that we have here today, unless somebody has some final thoughts, questions, or comments. All right. Well, if not, thank you very much.
Jim.
Have a wonderful weekend. And I really appreciate all of your participation, and hope you found this valuable, and I hope to see you again.
Thanks all. Have a good day.